Alright, for this week too, I've got several problems for you to just work on just to get used to the Jupyter interface and get used to calling packages like NumPy and SciPy. So I'm just going to go over a few quick things for you. One of the nice things about the Jupyter interface you can see is that you got a notebook, and in this notebook you can do actual coding and calculations, but you can also use these markdown cells. So for example, if I was to go ahead and add a cell here, the default is a code cell that we can evaluate. But if we go ahead and just change that to Markdown, now I've got a cell where I can put in all kinds of comments. I can use things like, if I use like a hashtag, you know, just like call this title. When I run this, same thing I do with code cells, it's just Shift Enter. You can see it creates this bold type section header, and if I double click in it, then I can go back to the actual coding for it. And so there's some defaults in here, right? This is a smaller header. You can use 3, smaller still, and then 4. I'm not sure if I ever did 5. Yeah, so let me go ahead and run that and see what they look like. Alright, so you can see there's different kinds of headers and things you can use, or just type into it like regular text. Alright, let me get rid of that. Okay, so those are the markdown cells. I gave you several examples in here in the student lesson, showing you how to get bold, italic, how to get highlighted text, for example. You can use text in the sort of Python format. So this is a Python format, so it's showing you what it would look like if it was actually in a code cell, or we can get Greek letters as well. Okay, so whenever you see these kinds of markdown cells, especially if I've got equations and things in it and it looks like you'd like to know what the coding is so you can use it as well, just remember double click in these cells. So if I double click in here, alright, so this is showing you how to do that. So double stars on each side of your text will give you bold. Singles will give you an italic. Accent marks here will highlight the text. And you have to do a little bit more work if you want it to show up as in like the coding format. So there's these 3 accent marks, then you have to tell it you want it coded in Python. Then you can write whatever you like and then just close them. Greek letters, you would use $signs, and then you can use this backslash and mu. Alright, and so the $signs are actually are a way to get Greeks as well as write equations. And the coding that goes in here is actually LaTex, if you have any familiarity with that. But that's our coding. Again, Shift Enter, and then you can see what you get. Alright, so that's for the markdown cells, just a few things to keep you thinking. Also, we could use these markdown cells for writing equations. So again, I'm going to double click in here and we can see what this looks like. So again, I need the $signs so that I can go ahead and use my LaTeX commands. So x_2 means x sub 2, x_3, that'll make that a superscript. If I want to write a fraction, I use this backslash frac, and then in curly braces, you go ahead and do your numerator, and then immediately curly braces and do your denominator. So let's see what that looks like. Okay, 3x over 2. Alright, if you had a longer equation, you don't need to put $signs around every single thing. You just have to keep your whole equation in here. Like if I wanted to say, alright, x sub 2 is equal to maybe mu times, let's see, we can actually do times, maybe sigma. Let's see what that looks like. There you go. Alright. Now, for some of the equations, I'll just tell you that there's a nice free hostmath.com where you can write equations, and it has a sort of a click interface. And once you get that, then we'll show you also the LaTex code to create the equation you want. So the LaTex code might look something like this, for example. And what you do is just copy that. Then you can come over to your Markdown cell, and you can just paste it in between the dollar signs, and you'll get an equation out. So this particular one says, so /int means integral, okay? And then the sub A means from A, and then caret B means your superscript, so that's the integral from A to B. It's going to then have a fraction, and your fraction is going to be, the numerator is everything in this first set of curly braces. So that is the square root of 4, and then, well, that's the fourth square root, sorry. And then what you're taking the square root of is ax. So the fourth root of ax over x. All right, and then you can put specific text in if you like. This is writing dx out, and you can see there. All right, so if I actually double click in here, you can see that this is the code that actually creates that equation. This one here, I had it suppress that so that you could see what the code was like on the previous screen. These accent marks tell it to basically ignore everything in here and just highlight it as text. So that's what's going on there. If you use double dollar signs instead of just the singles and put everything in between those, then it will automatically use a new space and center your equation. All right, so I have some other ones in there. You can go ahead and double click on those, and you can see, you know, how you could write like boundary conditions or something, or matrix form, summations if you want the arrow, or some couple of Greek letters. So just double click on the cell and it'll show you all of those. All right, so let's just go over this example problem. So we just want to calculate the number of atoms in a cubic meter of a BCC material, and we're given the atomic radius. So we know the volume of a BCC unit cell is given by 4r over the square root 3 cubed, and there's 2 atoms in a unit cell, so we've got 2 over the a cubed here, the volume, and that gives us atoms per meter cubed. And so that's how many atoms are in a meter cubed. Okay, as long as we put r in as in meters. So what we like to do is calculate this. So we're going to go ahead and import numpy as np. Then I'm going to write my equation out for the number of atoms. So you can see it here. Just notice that you've got to use stars, asterisks for all of your multiplication, right? And you're going to need to use double asterisks for powers. So this is 0.15 times 10 to the minus 9. Okay, we need the numpy for the square root, and then again we're going to cube all of that. So we got, again, the double asterisks. So we can go ahead and print that, and we can also use a little nicer format. So if we use a straight print, you can see it gives us 4.811, etc., etc., etc. But a little nicer way is here, the number of atoms in the BCC unit cell is 4.81 times 10 to the 28th atoms per meter cubed. So this is an F string, so we're going to have a string. So we got our string, that's single or double quotes is fine, around all of our text. Put an F out front immediately before the first quote mark, and that means it's an F string. And then we put all our text in here, and the F string looks for curly braces, and when it sees that, it goes and takes the variable that's here, finds the number outside of this print statement, puts it in here for you, and then formats it. So here the point to E means to use scientific notation and to use 2 decimals after the decimal point, 2 numbers after the decimal point, 4.81. Okay, so if I could change this to 5, and you can see we get 5 after here. And there's others that you can use as we go on. One of them is the floating point number, so that could be done as well. Okay, so we could do a floating point number. Oops, F for floating point. Okay, so the floating point number gives us the 2 decimals after the integer part. But you can see here the integer part is quite long, so we really do need the scientific notation here, but there's my 2 decimals showing up there. So I'll put this back to scientific notation, and there you go. Okay, so that's the F string. It's really useful for passing values into a print statement and providing some formatting support. And then we just continue on with our string output, atoms per meter cubed in this case. All right, some additional things. So you will need the NumPy for things like using the exponential or the square root, using cosines, things like that. You're going to need SciPy and import special if you're going to use the error function. One of your problems requires you to use an error function in the homework. And what else? In your homework you also have to write a function. This is, again, it's just the general format for a function. Just remember that colon, and remember that these are all indented, and then you can return the variable that you want to be kicked back out of your function. So, for example, this is the atoms per BCC unit cell. You can put commenting right in here as long as you use the hashtag. So this is just telling you, go ahead and put in the atomic radius in nanometers. This is going to go ahead and do the calculation. So it takes that atomic radius in nanometers and multiplies it automatically by 10 to the minus 9. That's why the units are important here. And then it returns the number of atoms. So I can go ahead and put in my 0.15, and I get my answer then kicked back out. All right, and so that is the general form. So whenever you define your own function, if it has just one variable, whatever you call that function, make sure you pass it one value. If you use more than one variable here, then you have to pass it a number in for each of the variables you defined. All right, I think that's about it for now.